So we're on page 215, talking about the atmosphere, which makes the clouds. And then we're going to talk about the clouds today, but we'll see if we can get through most of the comprehension checks before we.
Wait.
All right, so let's get started reading. So, the atmosphere. You know that an average-sized, white, fluffy cloud can weigh as much as 1,000 tons? What kind of material is a cloud made of that such a heavy object can manage to float so easily through the blue sky? A cloud is not made out of water vapor, as you may have heard. Water vapor is an invisible gas. Rather, a cloud is made out of very tiny water droplets. These droplets are so small that it takes over 1 million of them to make one raindrop. But where do cloud droplets come from, and how do they manage to get high into the air? So we're going to talk about how clouds develop and how they get so high. I want Sandra to start reading for me. The cool blue sky.
Okay, the blue sky. Did you know that in the snows at the equators, there are several tall mountains in the tropical regions that have snow on their tops? Snow falls at the top of high mountains because although the temperature at ground level may be much too warm for snow, the mountains reach high up into the upper levels of an atmosphere where temperatures are cold enough to allow snow to form. Warmed by the sun, the air radiates energy back into the atmosphere. Air in the lower troposphere absorbs most of this energy, allowing very little to pass on to upper levels. At higher altitude, because air is far away from the Earth, heat is much colder than the air near the Earth's surface. The temperature of the air at atmosphere to the most boundary called the tropopause is between 60 and 18 degrees below zero. The tropopause marks the location of the temperature inversion. A temperature inversion is a reversal in the direction of temperature change with a change in heat. In the troposphere, as a general rule, the warmest air is found near the Earth, so the Earth's surface, and the coldest a troposphere. The higher the air is, the colder its temperature, but above the troposphere, heat absorption of sun causes the air in the stratosphere to become gradually warmer. Later we will see how the temperature inversion at the troposphere acts like a lead to keep the weather breeze in the troposphere from penetrating higher up into the stratosphere.
Good job. All right, everyone look at the pictures on the bottom. You see Mount Kilimanjaro in Africa? Do you guys see Mount Kilimanjaro in Africa?
Yes.
All right, so you can see where the troposphere is at, right?
Yes.
And that's where it starts to get really, really cold. And then before that, you see the tropopause, which is about 2 miles up. That's where it gets negative 60 to negative 40 degrees. That's kind of like, that's what they were talking about, the temperature inversion right there. The place where, you see on the side right here? Right here on this side, these are the temperatures. So it stays really hot at the bottom and then it starts to get colder and then really cold and then it gets really warm again in the stratosphere. And so that's the temperature inversion where it's switches from cold to hot, hot to cold and then cold to hot again. All right, let's go to the next page. Monse, I want you to read for me.
Yes, teacher. Whether it takes the form.
What? 216, girl. Hello, Mark, turn on your camera.
times, Mister?
The 216, a recipe for clouds. You're not paying attention.
Mister 216. There are usually three mountain ingredients needed for cloud formation: water, resin, air, and dust. This combination is not very, very difficult to achieve because God has designed clouds to be the means of watering the earth. The first ingredient, the key for cloud formation, is water. To evaporate, water is placed into the atmosphere as a vapor. Most of the water vapor remains in the bottom of troposphere, very close to the Earth's surface, where evaporation takes place. Remember that warm air is able to hold more water vapor than cold air. That means that near the Earth's surface, where temperatures in the troposphere are the warmest, air can hold a great deal of water vapor. High up to the colder air is not capable of holding nearly as much. The second ingredient needed to make a cloud is rising air. When warm air begins to rise away from the Earth's surface, it takes its water vapor along with it, but is as the warm air rises, it begins to cool. Soon it reaches the dew point, the
Sorry,
lowest
Mister, my father was calling me.
Okay.
at which it is able to hold all at its water vapor. If the air rises and cools anymore, it has to get rid of some of the vapor through condensation. Water vapor condenses high in the air, forms and clouds. But there is a dear ingredient in the cloud reside. Without the particular item, clouds could not form because condensation would be impossible. In order for water vapor to condense, a solid object must be present for the water molecules to collect on as a liquid. For instance, water may condense onto the outside of a glass or onto a car window, but there are not such objects floating around in the sky where clouds form. How they how those condensations take place high in the air?
All right. So what do you think it is? What's the last ingredient that water vapor needs to collect to be able to fall down as raindrops? Or to form it? Well, they form as clouds, but what do you think is the last ingredient needed? Who knows? All right. And what's the last one? Dust. All right. Once I finish that paragraph right there.
The air is full of countless microscopic particles of dust. Sea salt, volcanic ash, pollen, and other substances. Their dust particles provide water molecules with billions of tiny solid surface for condensation. Where rising air cools below in dew point, if water vapor condenses to form very small droplets of water around the dust particles. Because of the smallness of the water droplets, they are able to stay suspended in the air without falling to the ground. We see them as a cloud drifting gently across the blue sky.
So clouds are actually water droplets.
I can read.
Yes, Carlos, read Moving Up in the World.
Okay. Now that we know clouds form when moist air rises, we need to talk about the different things that can cause air to rise. solar heating. When we talked about wines in the last section, we learned that the sun heat produces rising air. Solar energy beating down from the above heats a certain area of the Earth's surface hotter than the surrounding areas. The hot earth then makes the air above it warm. The warm air is pushed upward by the cooler air around it. As the air rises, its water vapor condenses to form clouds. On the large scale, the tropics are the warm spot where the air rises to form clouds. Remember that air over the equatorial regions is warmed and lifted by the sun before beginning its journey toward the north and south poles as a part of the Earth's wind system. Much rain falls in the tropics because large amounts of water vapor are changed into heavy rain clouds as the ascending air cools. But on a smaller scale, a parking lot or field is also capable of making its own cloud by the same method. Have you ever seen the sky dotted with lots of little puffy white clouds on a hot summer day? Each of these clouds was made then a bubble of warm air over a certain sun-heated area of land rose upward, releasing its water vapor by condensation to form the cloud. The flat bottoms of the clouds show at what height the temperature of the air fell below the dew point. If you watch these clouds closely for some minutes, you can see them growing in size while the ground continues to supply hot air. Then, as the wind carries them away from their birthplace, they gradually melt away to nothing. I continue.
No, that was good. Good job. All right, now let's talk about mountains. You can see how the clouds increase. Talk about mountains. Let's have Sandra. I want you to read mountains. Wait, did you read already, Sandra?
Yeah, Mr.
Peña, I want you to read.
I Mr.
Sorry, I'll go Peña and then John Carlos. Deal? Okay.
Mountains, when the wind blows across the earth, it often runs into an obstacle in its path. Usually, if the obstacle is small or narrow, the wind will flow around it, but if the obstacle is big enough, like an arrow of mountain, the wind may have to flow over it as moving air rises over the mountain. It could reduce some of its vapor to form a cloud. Many mountains are constantly covered with clouds because of the action of the wind passing on them. Front, I read first, Mr.
Keep going.
Fronts. Clouds are also made warm air and colder run into each other. The airways are that cause the different types of air to collide and mix. Remember that both the northern and the
The southern hemisphere are divided into three main belts. The trade which closest to the equator, the polar isle nearest to the poles, and the polar west in the middle latitudes between the trade whites and the polar whites. Of the three waves belts, the area of prevalent worst in middle latitudes has a greater variety in its weather in the region. Air flowing away from the equator range head into air flowing the opposite direction away from the coast. The coastal exchange water is a result of the costly air mixing a few masses of warm tropical air and cold polar air taking place over her. The huge masses of air that collide in the middle latitude from our source regions.
Keep going. Source region.
A source region is a large area of land or ocean with nearly the same temperature across the entire surface. They are directly above the region next on the characteristics of the torrent ground below it. If the torrent of the source region is cold, the air cools. If the torrent is warm, the air actually warms. If the torrent is moist, the air picks up water vapor. The air over the region continues to change until it becomes what is called an air mass, a singular unit of air with uniform temperature and humidity characteristics. There are many different types of air masses.
All right, let's stop there. Very good. So we see how mountains make clouds and fronts make clouds. John Carlos, will you keep reading from there?
There are Mr. Wall continue when continental tropical.
Yeah, continental tropical.
Continental tropical air masses are hot and dry, forming over the deserts and plains of some continents, especially in summer near the equator. Maritime tropical air masses pick up much moisture from warm seas. The colder ocean outside the tropical region produces marine polar air masses with cool wet air, cold and dry continental polar air mass for over large areas of land such as Siberia and Canada. In the northern hemisphere, Arctic and Antarctic air masses which develop over the ice and snow of the pole are very cold and rather dry air. Look at the map to see how these different kinds of air masses influence the weather of the United States. After some time, an air mass may begin to move away from its source region, traveling very slowly as an air mass moves. It gradually picks up the characteristics of the terrain that it passes over. For instance, if an air mass falls over a hot desert, its air will be hot and dry, continental tropical. But if it then moves out over an ocean, it becomes warm and moist marine tropical. Most often, air masses move toward the mid latitudes in the middle of latitude, and air masses can travel for before bumping into other air masses. Usually, different air masses have different characteristics. One will have warmer air than the other. For instance, when two air masses meet, a very definite boundary line forms between the two different types of air. The boundary between two air masses is called a front. There are different types of fronts depending on which air mass is moving forward, pushing back the other. At a warm air pushes back cold air, but at a cold front, cold air pushes back warm air. When advancing warm air runs into a mass of colder air, it is lifted up over the top of the cold air in a very thin wedge, and begins to push the cold air slowly backwards. As the warm air rises, it cools and releases some of its moisture through condensation to form clouds. The clouds form a boundary between the warm air and the layers of cold air beneath it, and the type of the wet speed of rising warm air. Continue the writing.
Yeah, just finish it.
The clouds are very high and dim, but they lower and thicken as warm air gets closer to the Earth's surface. From your viewpoint on the ground, a warm front appears as a long period of cloudy, rainy weather, sometimes lasting several days and followed by warmer temperatures. Cold fronts travel more quickly than warm fronts. Heavy cold air moves forward and ground level buzzing into the lighter warm air and pushing it rapidly over very tall terrain, clouds build up in a narrow band along the edge of the rising warm air. Cold fronts bring a fourth period of rainy weather and are usually followed by clear skies and cooler temperatures. Often the weather of a cold front is severe, with heavy rains and wind, lightning, thunder, and maybe even hail or tornadoes.
Very good. All right, so now we're gonna work on this chapter checkup, or the comprehension check 8.3. So make sure you have your notebook, and then we'll.
I already do it.
What you say, mister?
Monse, I know if you leave, you can leave your screen there. Make sure you're paying attention.
What, mister?
Make sure you're paying attention and you don't leave, because I know you can freeze your screen when you leave. All right, 8.3. We're working on our com check. You already did it. Good job. We just want to make sure it's correct. If it's correct, then it's correct. If not, then it's not. And you can change it. All right.
Mister, we need to do that comprehension check.
Yeah. We're going to work on it right now.
Mister, can I look for a pencil?
Yeah, well, hurry, because we don't have a lot of time and I want to be able to help. All right, so we have the first one. It says, read each statement,
Mister,
true or false. Yes, Monse?
we are doing for comprehension check 8.3 to 8.5, right?
8.3 and 8.4.
Okay.
All right, first one. It says, read each statement and answer true or false. Monse, will you read the first one for me?
Yes. Read each statement and answer true or false. False. Most collisions between air masses take place in the middle latitude.
Is that true or is it false?
True.
That is
That
true.
is true, mister. Mister, we just only put the same that you have there.
Yeah. Warm air grows warmer as it rises. Is that true or false?
That be
It's false.
false.
Lizzie, will you read number C for me?
In order for condensation to take place, water molecules must have a solid surface to create their own.
John Carlos, is that true or false?
Hi, Mr.
Yeah, true or false?
True.
It's true. Peña, read me D.
Okay. D. A from in the boundary between two source regions.
True or false?
I think false.
That is correct. Sandra, read me E. Sandra's gone. Carlos Abraham, read me E.
Okay. Clouds are made out of water vapor.
True or false?
True?
No.
It's
It's false.
false. Sister,
They're made out of water droplets. Yes, Peña.
can you give me a list that the homework that I have done? This.
What you owe?
Yeah.
Yeah, but I can't do that right now. But I will. All right. Hello, Mar, are you there? Because if you're not, I'm going to kick you out of my class. Monse, read me F.
Much water vapor remains in the bottom of the troposphere near the Earth's surface. That is true, mister.
That is true. All right, and let's go with, who else is there? Lizzie, read me G.
If a source region has warm terrain, it will produce a warm air mass.
Is that true or false?
True.
True, good job. All right, now we're on to number 2. John Carlos, would you read me number 2 for me?
Yeah, Mr. Identify each statement as a characteristic for a warm front or a cold front.
All right, so we're either going to put warm front or cold front. That's all we're doing in this one. Now, it's for the first one. It says warm air pushing back cold air. Is that a warm front or a cold front?
Warm.
It is a warm front. On B. B is cold air pushing back warm air. And a warm front?
Cold front.
Yes, cold front.
Cold.
Carlos, I want you to do C. Carlos, do C for me.
Me, mister?
Yes, you make sure you're paying attention, bud.
Because I was doing The B. Okay. Often brings severe weather with heavy rain and wind, lightning, and sometimes hail or tornadoes.
All right. Is that a warm front or a cold front?
Cold front.
Cold front. Good job. All right. Peña, read me D.
Travels faster than the other type of route.
Is that a warm front or a cold front?
The water,
No, not warm. It's a cold front.
the cold.
All right, Lizzie, will you read me E? Carlos, keep your camera on.
Followed by warmer temperatures.
Warm front or cold front? Lizzie, is it a warm front or a cold front?
Warm front.
Good job. All right, the next one says warm air rises slowly over cold air in a thin wedge. Jared, Jareth, is that a warm front or a cold front? Monse, is that a warm front or a cold front?
Cold, mister.
Yee. It's a warm front. And then our last one, John Carlos, will you read it for me?
What is an air mass?
No, it's a narrow band of rain clouds forms as water is pushed.
A narrow band of rain clouds form is that is one.
Yeah.
A narrow band of rain clouds forms a warm air. It pushes rapidly upward.
Is that a
Cold.
cold front? Good job. All right, now let's go to the next one. It says, read it for me, Carlos. Number 3.
Okay. What are the three ingredients in the cloud recipe?
All right, who can tell me what are the 3 ingredients in the clouds recipe?
Hi, mister.
Peña, what is it?
Is water, resin, and air and dust. Water, resin, air, and dust.
Good job. Water, rising air, and dust. Those are the 3 ingredients to form a cloud. Name 3 things that cause air to rise.
Solar heating, mountains and fronts.
Solar heating, mountains, and fronts. Good job. All right, Giancarlos, read me number 5.
Okay. What is the name of the upper boundary of the troposphere?
Tropopause.
Tropopause. Very good. It's the tropopause. And then our last one, it says, what is an air mass? You can tell me what an air mass is.
Can I say it, mister?
Yes, you may. Let's go for it.
A single large unit of air with uniform temperature and humidity.
Very good. It's a single large unit of air with uniform temperature and humidity characteristics.
Finish, mister.
All right. That is all we're going to do for today, except for you guys still have one last one, okay?